Hello all. So in today's class we'll begin the fourth module. So fourth module is on measure and integration in a product space. അപ്പോൾ ഫോർത്ത് മോഡ്യൂളിൽ നമ്മൾ മെയിനായിട്ട് നോക്കാൻ പോകുന്നത് നമ്മൾ സിംഗിൾ ഇൻറ്റഗ്രൽസ് ഡിഫൈൻ ചെയ്തു. അപ്പം ആദ്യം മെഷർ എന്താണെന്ന് ഡിഫൈൻ ചെയ്തു, മെഷറബിൾ ഫങ്ഷൻ എന്താണെന്ന് ഡിഫൈൻ ചെയ്തു. സോ യൂസിങ് ദാറ്റ് വി ഡിഫൈൻഡ് what is integration. Integration for simple function, bounded function define ചെയ്തു. For non-negative function and for general functions we defined the concept of integration. Now we will look at the notion of double integration. For defining double integral, there you will have two spaces, x and y എന്ന് പറയുന്ന രണ്ട് സ്പേസ് ഉണ്ടായിരിക്കും, and there associated to that we will be having two measures. അപ്പോൾ now instead of the usual measurable space, അപ്പോൾ usual measurable space എന്ന് പറയുന്നത് we will have a set x and a sigma algebra of subsets of x will be there, and there will be a measure defined on that space. In order to define a double integral, we will have what is called a product space. We will have x എന്ന് പറയുന്ന ഒരു x ഇവിടെ x സ്ക്രിപ്റ്റ് എന്ന് പറയുന്ന ഒരു മെഷറബിൾ സ്പേസ് ആയിരിക്കും, അതുപോലെ y സ്ക്രിപ്റ്റ് j എന്ന് പറയുന്ന ഒരു മെഷറബിൾ സ്പേസ് ആയിരിക്കും. ഇനി we will have a product space which we are going to denote by x cross y and script s cross script j, and we will be having a measure defined on that which is called a product measure, which we denote in the form mu cross r. In today's class we will look at how do we define the space x cross y. X cross y എന്ന് പറയുന്ന സ്പേസ് എന്താണ്, what is a measurable rectangle. If you form then x cross y ക്ക് അസോസിയേറ്റഡ് ആയിട്ട് നമുക്കൊരു സിഗ്മ ആൾജിബ്ര ഫോം ചെയ്യണം. അവിടെയാണ് നമ്മുടെ പ്രോഡക്റ്റ് മെഷർ ഡിഫൈൻ ചെയ്യുക. ഓക്കെ, അപ്പോൾ ഹൗ ടു ഡിഫൈൻ ദാറ്റ് സിഗ്മ ആൾജിബ്ര. അപ്പോൾ സിഗ്മ ആൾജിബ്ര എങ്ങനെയാണ് ഡിഫൈൻ ചെയ്യുന്നത്? സോ വിൽ ഡെവലപ്പ് സച്ച് എ സിഗ്മ ആൾജിബ്ര, ആൻഡ് then similar to what we have done in the initial modules, we'll define what is called a measurable function. So if you have a function of two variables x and y, അത് എപ്പോഴാണ് measurable ആവുക, and then we'll define the double integration. അപ്പോൾ we'll be setting up, നമ്മൾ initially integration വേണ്ടി എന്തൊക്കെ സെറ്റ് ചെയ്തോ സിമിലർ ആയിട്ട് we'll be looking now in the product space what all we require to bring the notion of double integral. So that will be what we'll be doing in the fourth module. So double integration like വരും, then we'll see the famous Fibonacci theoremത്തിന്റെ proof ആയിരിക്കും നമ്മൾ കാണുക. That means double integration, you can change the order of integration. The value of integral remains the same. അപ്പോൾ when is that possible? We'll see that, and we will see the proof of Fibonacci theorem. So that is what we will be doing in the fourth module. Let us move on to the definitions. So first we'll look at what is called a Cartesian product. That is the usual definition of the Cartesian product. So if you have two sets x and y by Cartesian product, so that is denoted by x cross y. X cross y is defined as set of all xy such that x belongs to x and y belongs to y. So that is an ordered pair of the form, collection of all ordered pairs of the form xy, where the first entry comes from capital X and the second entry comes from capital Y. Usual Cartesian product. So that is what we mean by x cross y, which is a Cartesian product of sets x and y. Now let us look at what is called a rectangle. Now by a rectangle on x cross y, we mean that is a set of the form a cross b such that a is contained in x and b is contained in y. So consider, so if this is x and y, you can imagine a rectangle to be something like this. So we have a contained in x and b contained in y. So A cross B is this rectangle. So that is you take any subset of x and any subset of y, then A cross B is called a rectangle on x cross y, and clearly A cross B will be contained in x cross y. And now we'll look at, so this is the definition of a rectangle, what is called a rectangle. Now next definition we have is called a measurable rectangle. Now a rectangle is said to be measurable. അപ്പോൾ എക്സ് സ്ക്രിപ്റ്റ് എസ് എന്ന് പറയുന്ന ഒരു മെഷറബിൾ സ്പേസ് ആണ്, അതുപോലെ വൈ സ്ക്രിപ്റ്റ് ജെ മെഷറബിൾ സ്പേസ് ആണ്. നൗ വി കൺസിഡർ A belongs to script S. That means A is a measurable subset of X. Script S nu parayna, that will be a sigma algebra, or that is a collection of measurable subsets of X. Aduvale script J is a collection of measurable subsets of Y. Now consider A belongs to script S. Again A will be contained in X. അതുപോലെ if you take B belongs to script J, B will be contained in Y. Now take A cross B. So this will be again a rectangle കാരണം A contained in B ആണ്, അതുപോലെ B contained in J ആണ്. So we are taking two sets and now they are measurable also since they belong to the sigma algebra. Now a rectangle formed this way is called a measurable rectangle. So A belongs to script S and B belongs to script J, then A cross B is called a measurable rectangle. Now also we can see that X cross Y, so X will belong to script S and aduvale Y will belong to script J. So X cross Y is also a measurable rectangle. Now the representation A cross B is not unique always. So when you represent a set in the form A cross B, that can be maybe denoted in other ways also. So such a representation is not always unique. So for example, if X and Y are non-empty sets, so you take the empty set. So phi can be expressed as phi cross phi. So this is one representation of phi. Now by the property of Cartesian sets, we know that if one of the sets is empty, anganeyanankil x cross phi will be equal to the empty set. So this will be another representation of phi. So phi can be represented as x cross phi nu ezhudam, allengil phi can also be represented as phi cross y. So in this way we can see that such a representation need not be always unique. So phi cross phi will be equal to x cross phi, so which is equal to phi cross y. So a representation of the form A cross B is in general not unique. So now if you take non-measurable set, so consider A, which is a non-measurable set. If you look at A cross phi will be equal to phi. So in that way we can say this is also measurable rectangle കാരണം A cross phi equal to phi ആയിരിക്കും. So this will be equal to phi cross phi. Now phi belongs to script S and also phi belongs to script J. So therefore phi cross phi is a measurable rectangle. Now A cross phi is equal to phi cross phi. So that way we can say that if A is a non-measurable subset, then also we can obtain a measurable rectangle from it. A cross phi measurable rectangle ആയിരിക്കും. Similarly, if you take B to be a non-measurable subset of Y, so we have B contained in Y, but B is a non-measurable subset. If you take phi cross B again, phi cross B ne equal to phi cross phi nu ezhudam. Now phi cross phi is a measurable rectangle, so that way phi cross B is a measurable rectangle. So therefore if you have a representation of the form A cross B is non-measurable if and only if ini ivide A non-measurable മറ്റേ സെറ്റ് empty set ആണെങ്കിൽ this will be equal to 5, we will get a measurable rectangle. Now if you have a case where A cross B രണ്ടും നോൺ മെഷറബിൾ സെറ്റ്സ് ആണ്, A നോൺ മെഷറബിൾ ആണ്, അതുപോലെ B is not empty and B is non measurable. In that case this will be a non measurable rectangle. So that is the case where we obtain a non-measurable rectangle. So A cross B is non-measurable if and only if A യും B യും രണ്ടും non-empty ആയിരിക്കണം, അതുപോലെ രണ്ടും non-measurable ആണെങ്കിൽ മാത്രമേ we will get a non-measurable rectangle. So the next definition is an elementary set. Now by an elementary set we mean that is a union of finite number of pairwise disjoint measurable rectangles. Suppose we have say measurable rectangles which are disjoint. Suppose this is V1, this is V2 and this is V3. So these are disjoint sets. V1 measurable rectangle aanu, V2 measurable rectangle aanu, V3 disjoint rectangle aanu. So we can see that they are pairwise disjoint. So by an elementary set you mean, so that is something of the form V1 union V2 union V3. So it is a union of finite number of pairwise disjoint measurable rectangles. Now the class of all elementary sets is denoted by script E. So elementary, by elementary set you mean that's a union of finite number of pairwise disjoint measurable rectangles. The collection of all elementary sets is denoted by script E. Now we will actually show that script E is an algebra. So we will move on to the proof of that. So we will show that script E is an algebra. The proof is done in നമ്മളൊരു 4-5 പാർട്ടായിട്ടാണ് പ്രൂവ് ചെയ്യുന്നത്. So in order to prove a collection is an algebra, so we must show that it is closed under complementation and it is closed under union. So that means if A and B belongs to the algebra, we need to show that A union B belongs to the algebra. അതുപോലെ A belongs to algebra ആണെങ്കിൽ A complement belongs to the algebra. So that is what we need to show. അപ്പോൾ we will be proving the theorem in ഒരു 5-6 പാർട്ടായിട്ടാണ് നമ്മൾ പ്രൂവ് ചെയ്യുക. So we will move on to the proof now. Showing that script E is closed under disjoint union. അതായത് രണ്ട് disjoint ആയിട്ടുള്ള elementary sets എടുത്തു കഴിഞ്ഞാൽ we will show that it is closed under union. അതുപോലെ then we will show that script E is closed under finite intersection, and then using that we will show that it is closed under complementation. Measurable rectangular complement ആദ്യം നമ്മൾ closed ആണെന്ന് കാണിക്കും. Then using that we will show that script E is closed under complementation, and then we will show that it is closed under union. So first we will be looking at how to show that script E is closed under disjoint union. So let us look at the proof. Script E is obviously non-empty കാരണം script if you take x cross y, so we are defining script E to be the collection of all elementary sets on x cross y. So x cross y itself belongs to script E. So therefore script E is a non-empty set.